Okay, today we're going to be talking about comparing fractions. So I have two students who have given me two answers of what they believe is equivalent fractions. So I have Brian, who believes that 1/2 is equal to 1/4, and I have Angie, who is believing that 1/4 is equal to 2/4. And Brian thinks that it is 1/2 and 1/4 that is equivalent because both of the top numbers are 1, and Angie believes that 1/2 and 2/4 is equivalent because both denominators are equal to 4. So today we're going to talk about which student is correct and how we can figure that out. So we're going to start out with talking about using our pattern blocks. So I have created a square here, and it has 4 parts to my square. So it has 1, 2, 3, 4. You can see it when it's a little bit spread out. So if I put these together, and I need to show what 1/2 of this square is. So I split it in half. So I have a part over here and a part over here, which equals 1/2. Now, with each of these halves, we have 2 parts in each half, which makes each of these halves split into a 1/4. So we have 1/2, 1/2, and then we have 1/4, 1/4, 1/4, 1/4, and that all together makes a whole. So Brian is saying that 1/2 is equal to 1/4. Well, here's our half, and then this would represent a 1/4. And now we can see that our 1/2 of our square does not equal a 1/4 of our square. So just because they have the same numerator does not mean that they are the same, they are not equivalent fractions. So next we're going to talk about Angie's, and she believes that 1/4 is equal to 2/4 because they have the same denominator. So we're going to go ahead and we're going to split our 1/4 off, so we know that this square represents 1/4, and she's saying it is equal to 2/4. So we're going to pull 1, 2, and now we see that 2/4 is much larger than 1/4. We can also see that 2/4 is also equal to 1/2 of my square. Okay, next we're going to talk about this same problem with our rods that we have here. So I have 3 different rods, and when you see them all together, they're all the same size. They're the same length. So we have our 1 whole. This represents our whole fraction. And then we have our purple, which is representing our 1/2s. So we know that 1/2 and 1/2 equals a whole. And then our red is representing 4ths. So we know that 1, 2, 3, 4 pieces of 4ths also equals 1 whole. So Brian said that 1/2, so we're taking one of our 2 halves, is equal to 1/4. So we're going to take one of our 4ths. And you can see, let me stand these up, that those are not equivalent. Our 1/2 is bigger than our 4th. And Angie says that 2/4, so I'm going to pull down 2 of my 4ths, are equal to 1/4. And we see that 2/4 is bigger than 1/4. And you can also even sub it out and see that our 2/4 together also equal a 1/2. Okay, and lastly, we're going to use a number line. So I have drawn out a number line counting by 4ths. So if we have a number line beginning at 0 and ending at 1, we know that the middle is 1/2. So we put a line down the center. And I know that when I compared my rods, that 1/2 was also equal to 2/4. So I put 1/2 or 2/4 here because they can mean the same thing. And then I split in between my 1/2 and my 0 into 1/4 because I know that 1/2 of a 1/2 is equal to a 1/4. And then I did the same here with my 3/4, as I know that if I have 2/4 and my 1, I need to add 2 more 4ths but I know that in between my 2/4 and my 1 is 3/4. So I have that. So Brian is saying that 1/2 is equal to 1/4, and you can see that these two are not the same number in the same place on the number line, so that would not be correct. And Angie is saying that 1/4 is equal to 2/4, and you can also see that those are not on the number line. So both of these students they were able to find the pattern that there were both 4's on the denominator and 1's on the numerator, but we can now see that if we're finding equivalent fractions, 1/2 would be equivalent to 2/4.